So in this video we're going to sketch a plane when it's missing one or more of the variables. So here it says sketch the plane given by 3x plus 4z equals 12, and what we want to notice is that the y variable isn't showing up, so there's a sense in which this is really 0y plus 3x plus 4z, and more importantly what this means is this plane doesn't depend on your choice of y. So we start off similar to how we did in the previous video. We'll let x equal 0, and in fact we'll let y equal 0. Y, because the equation doesn't depend on y can be any value that we wish it to be. And then once we let x and y be 0, this will zero out and leave us with 4z equals 12, which means z is equal to 3. So we get the ordered triple 0, 0, 3 being the intersection of this plane with the z-axis. And then similarly we'll let y equals z equals 0, and if we do that, this will zero out this term and leave us with 3x equals 12, so x will be equal to 3. So we get the ordered triple 3, 0, 0, which is right here. We get the ordered triple 3, 0, 0, and then that gives us a trace of the plane in the xz plane. And now because this plane doesn't rely on x, what we'll do is draw a line through the point of intersection with the z-axis. We'll draw a line through that point but parallel to the y-axis, and then we'll draw a line through the intersection with the x-axis that is parallel to, again, the y-axis, because the y variable in this case doesn't affect the plane. And then if I want, I can connect these up. Of course, then if I do that, that's going to kill that. And then draw this guy. It's like a lean-to. And so here's a representation of this plane, and the key is to recognize that the plane that we get is parallel to the y-axis. So if we have an equation of a plane and it's missing one variable, the plane is going to be parallel to the missing axis. So we're going to be, in this case, we're missing the y-axis, is the y variable's missing from the equation, so the plane will be parallel to the y-axis. If this were y instead, if we had x and y, then we would wind up with a graphical representation that would need to be drawn parallel to the z-axis. If the y and z variables were there and the x variable were missing, we'd wind up with a plane that would be drawn parallel to the x-axis. So we can, in three-dimensional space, actually have two variables missing from the equation of a plane. So in this case, all we have is 3x equals 12, which if we divide both sides by 3 just gives us x equal to 4. So we have 4, 0, 0 being the intersection of the plane with the x-axis. That's this point right here. And because both the x and the y axes are missing, the graph of the plane has to be drawn parallel to each of those axes. So if I were thinking about this, I would draw a line right here parallel to the z-axis. I would draw a line parallel to the y-axis because the y variable is missing. Draw a line parallel to, as best as we can, parallel to the y-axis, parallel to the z-axis, and then this is a representation of that plane that contains the point 4, 0, 0. In fact, this plane is has to be parallel to the y-z plane. Because each of the y and z variables are missing, the plane must be parallel to each of the y and z axes, which makes it parallel to the entire y-z plane. And in fact, this plane is actually hitting the xy plane at a 90-degree angle. So when we have an equation for a plane that's missing two of its variables, the plane must be parallel to the plane represented by the missing variable. So here y and z were missing, so the plane that I get is parallel to that YZ plane. Had I had an equation like z equals 2, then z equal 2 would be right here. You'd get a plane. You'd have to draw it parallel to the x-axis, parallel to the y-axis, parallel to the x-axis, parallel to the y-axis, and the plane z equal 2 would be parallel to the xy plane. So it'd be like a flat table sitting 2 units above the xy plane.